Okay, welcome back to math class. Yesterday we talked about how to solve whenever we had it in the form like this. Using the zero property, the zero product property. You remember, like I said, whenever this equals 0, we know that one or both of these must equal 0. So what we're learning today is whenever it's in this form, equaling 0, how do I solve that? Now, what we're going to have to do is figure out how to get from here to here. If you remember, way back whenever we were multiplying polynomials and they looked like this, what I had you do was multiply everything in this parentheses by everything in this parentheses using the distributive property. So the first way to do that is by splitting it up and having x times x plus p plus m times x plus p. We're multiplying each piece of this by each piece of this. And then once I got this far, I would distribute. X times x is x squared plus x times p, which is px, plus m times x plus m times p. Now it's a little bit confusing with the variables, so let's put in some numbers. X plus 3, x plus 4. Do the same thing, x times x plus 4 plus 3 times x plus 4. We do x squared plus 4x plus 3x plus 4. Okay, now both of these equations, I stopped here, but they're not finished because both of these equations have like terms with the same variable at the same exponent level. So what I'm going to do with this is I'm going to do 4x plus 3x is 7x. Oh, 3 times 4 is 12. What was I doing? Yeah, so I combined these to be 7x, and I got x squared plus 7x plus 12 left over. Same with this one. We have px and mx, and what's going to happen is I'm going to have x squared plus, now see here I did 4 plus 3 gave me 7x, so I'm going to do p plus m times x plus mp. I just don't know what p and m are. Now what you'll notice about this is that it's in this form that we're trying to solve for, but what we have is m times p as our c and m plus p as our b in our equation. And that's going to happen every time. We had 3 plus 4 and 3 times 4, which was 12. So basically, when we have something that looks like x squared plus bx plus c, we can break that down into x plus m, the backwards of this, x plus m times x plus p when, and that's an if m plus p equals b and m times p equals c. So basically what I've said is if you have an equation like this, x squared plus 7x plus 12, we can break it down into two binomials if m plus p equals our b, so 3 plus 4 equals 7. And m times p equals c, so 3 times 4 equals 12. So what we've been doing is starting here and working our way here. But today we're going to start with this one and try to get back to the top. So let's practice one and I'll show you the best way to do it. I'm gonna leave this here for reference. Okay, so if I have d squared plus 11d plus 24 what I have to figure out to break it down into two separate binomials is I have to figure out what two numbers multiplied together equals c, but added together equal b, because we're saying m plus p equals b and m times p equals c. This is only true when these are true. So what I'm going to do is I'm going to make myself a little chart that's the factors of 24 and then the sum of those two numbers. 24 is our c, and we're trying to figure out m times p has to equal c, so we're figuring out what two numbers multiplied together will give us c, and then we're going to choose which one of those two numbers, when added together, give us b. So first things first, we'll break down 24. First of all, we have 1 and 24, right? 1 times 24 is 24. Then I have 2 and 12. 2 times 12 is 24. I could do 3 and 8. I could do 4 and 6. So those are all of our factors of 24. Now what I'm going to do is I'm going to add each of these together to see which one gives us 11. So 1 plus 24 is 25. 2 plus 12 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. So this is the one that gives us 11. So this is the one that we're going to use. Now that we know 3 and 8, 3 times 8 is 24. 3 plus 8 is 11. I can just break this down into d plus 3 times d plus 8. We've taken this into this by figuring out what our m and our p are. Now if you want to check if you did it right, all you have to do is multiply them out and you should come back out to this number. So let's try that together. D times, let's split it up. Our d times d plus 8 plus 3 times d plus 8. D times d is d squared plus 8d plus 3d plus 3 times 8, which is 24. We have like terms, so d squared plus 11d plus 24. That's our same. One is up here. So we know we got it right, and this is our answer. Once you know the pattern, it's not too complicated of a thing. It's just a matter of figuring out which two numbers multiplied together also add up to be the same number. All right, so that's if we have all positive numbers in our equation. But let's see what happens if we have a negative number. So let's do x squared minus 11x plus 28. So we have a negative b. What happens when our x squared plus bx plus c becomes x squared minus bx plus c? what's going to have to happen is our numbers, our sum, is going to have to be negative, right? They still have to multiply together to be 28, but they have to add together to be a negative number. So what I'm going to do when I pull out my factors is I'm going to choose negative numbers as factors of 28. But 28 is positive, and if you guys remember, two negatives equal a positive. Two negatives multiplied together equal a positive number. So we're going to do factors of 28 just like before, but I'm going to do two negative numbers so that I can get a negative sum. So I'm starting with -1 and -28, because -1 times -28 will give me positive 28. And I'm going to do -2 and -14. Then I'm going to do -4 and -7. Now if I start adding these together, -1 plus -28 is going to give me -29, so that's not the right answer. Then we're going to do -2 plus -14 gives me -16. -4 plus -7 is going to give me -11. So that's the one we want. This is the one we're going to use. Now I'm going to plug it in over here into my equation. Get x minus 4 times x minus 7. Now it works because -4 times -7 is positive 28, but -4 plus -7 is -11. So that's what happens when B is negative. How about when C is negative? Let's try one of those. Okay, yeah, so this time our B is back to being positive, but our C is negative. We're going to do y squared plus 13y minus 48. So our B is positive, but our C is negative. So we have to find factors of -48. Now to factor something, for the product of something to be a negative number, that means I have to be multiplying a positive number by a negative number. So all of my factors should end up being a positive number and a negative number. And what I'm going to do, so I'm going to start with -1 and 48. But -1 plus 48 is just 47. So that's probably not the answer we're looking for. Then I'm going to try -2 and 24. But -2 plus 24 is it's 22. So that's still bigger than 13. So now I'm going to try -3 and 16. -3 plus 16 is 13. So that's the one we're looking for. So we're going to take that one and we're going to plug it in to our parentheses. So we're going to go y minus 3 times y plus 16. Because 16 times -3 is -48. 16 plus -3 is 13. All right, so this is how you factor them when it's an equation like this. The final step to all of these problems is, once you've figured out this far, is setting it equal to 0. Because I'm trying to solve these equations. So I've taken an equation that looks like this. I've factored it out into two binomials. Now I'm going to use my zero product property that we learned yesterday to figure out what y could equal. So if you guys remember, we're going to take each binomial and multiply it, and set it equal to 0 independently. So what we're saying is y could either equal, or we said 0 equal to y minus 3. So either y minus 3 is 0, or y plus 16 is 0. So we're gonna add 3, so, right? So either y equals 3, or minus 16, or y equals negative 16. So to solve it, you just have to factor it like I showed you the rest of the lesson. Then you set it equal to 0 and use our zero product property from yesterday.